Okay. This is going to be from discussion 2, exercise number 5, proving that the sum from k equals, let's be from 1 to n of k is in fact equal to n times n plus 1 over 2. So what we have here is the sum of just k, so 1 plus 2 plus 3 plus 4 plus 5. Well, let's write this out. And actually, I'm going to modify it a little bit. It might be easier to prove if I move this 2 over here. I could have 2 times the sum of k equals n times n plus 1. So that's what I'm going to do. I'm going to take this 2 times the sum of k equals 1 to n of k. And I'm going to show this equals n times n plus 1. Alright. So this is going to be 2 times the sum 1 plus 2 plus 3 up to n. Okay. Well, 2 times this sum is going to be the same as this sum, 1 plus 2 plus 3 up to this n, plus itself. Okay. Well, I know what this is. I can take n plus 1, so I'm going to match up the last part of this sum with the first part of this sum. Then I'm going to take the previous one, match it up with this guy. So this is n minus 1 over here. And we keep doing that. I'm going to match everything up all the way across. So what you end up getting is this first one will be n plus 1. And then the next term I'm going to go down from n to n minus 1. And go up from 1 to 2. So n minus 1 plus 2. And we go down one more, so I get n minus 2. Go up 1 to plus 3. I'm going to keep doing this until I get to, what's down here? Until I get to all the way down to 1 plus, and then I'll have n, just n. Right. So that will be this one. So this 1 plus n, and then before this will be 2 plus the n minus 1 over here. And then over here I've got this last n plus this one. Well, if you look carefully, each of these terms is equal to n plus 1. So n plus 1, n minus 1 plus 2, that's n plus 1. N minus 2 plus 3, that's n plus 1. In each term going, I'm decreasing this first part of the sum by 1 and increasing this part of the sum by 1, all the way until this decreases down to 1 and this increases up to n. Well, no matter what, in each term, that means you'll get n plus 1 because you're not actually changing the sum. You're subtracting 1 and adding 1. Okay. So the question is, how many of these terms do I have that are all equal to n plus 1? Well, you look, you start this n, and you go back, there's n possible terms, so there's n combinations here. So there's n times n plus 1. So we have n plus 1 n times here, is what this previous step is. Okay. Well, what is this n times n plus 1? Remember, we started out with 2 times the sum of k. Alright, well, it's 2 times the sum of k. K equals 1 to n. We'll just divide out the 2 from both sides, and you end up with the sum of k equals 1 to n of k. It's n times n plus 1 over 2.